All right, now we're going to put it all together. And again, you've seen this all in Algebra 2. So many applications of business economics involve a process called optimization. No way that fits there. In which you are asked to find the minimum cost or the maximum profit or the minimum use of resources. Okay? So minimum cost, minimum use of resources, or the maximum profit. All right? One way to find this optimization is something called linear programming. I'm just going to abbreviate that there. The only way we'll solve linear programming is by graphing. Okay? If there's a solution, it must occur at a vertex of the feasible solutions. Okay? A vertex also will refer to them as corner points. And to find which vertex is the maximum or minimum, plug in the ordered pair into the objective function, which we referred to in the previous lesson. And remember, that's always going to be a z equals. Okay? So like right here, this would have been formed by this line, less than, this line being shaded less than, this line being shaded greater than, this one would have been greater than, this would have been less than, and this area here would have been the overlapping area of all those shaded spots. That's the feasible region. And then we would have 1, 2, 3, 4, 5 corner points to plug into our z function, our z objective function, and figure out which one gives us the minimum or maximum of whatever we're looking for. Okay, so find the maximum value for 4x plus 2y. Z equals 4x plus 2y. We're going to come back to this at the end after we graph everything. Now remember, these just give us the first quadrant. Okay, so that means we're going to be only in here. All right, so y is less than or equal to 2x plus 4. So we go 1, 2, 3, 4. All right, and we're going to have a positive slope of up to right 1. Like so. It's going to continue down here, but we really don't care. Okay, so less than, we plug in 0, 0. So this would be 0 is less than or equal to 4. That's a true statement. So we're going to shade the side of the line where 0, 0 is, right here, which means we're going to shade this way. And we don't really care about the rest. We're just caring about the first quadrant. All right, I'll change colors. 3x plus 9. So this was 4, 5, 6, 7, 8, 9. A negative 3 slope, which means down 3, right 1. Down 3, right 1. Down 3, right 1. And we're going to connect we want to use a straight edge whenever we can. I'm doing my best. And we're going to test 0 is less than 9. That's a true statement, which means we're going to shade this way. Again, we really only care about that first region. All right. So that gives us an overlapping area of up here, that dot right there, down to here and here. So that quadrilateral is our feasible region. So what are my 4 points? I have 0, 0. I have 3, 0. I have 1, 6. And I have 0, 4. Okay. Now what I'm going to do is plug each of these in to this equation. So 4 times 0 plus 2 times 0, well, that equals 0. All right? 4 times 3 plus 2 times 0, well, that's just going to be 12. 4 times 1 plus 2 times 6, that's going to be 4 plus 12 is 16. And 4 times 0 plus 2 times 4, which will give me 8. Now we're looking for maximum, and we say the max is at 1, 6. And if this was a word problem, let's say we were making, necklaces and earrings, okay? And X was necklaces and Y was earrings. We would make 1 necklace and 6 earrings to maximize profit. All right? Here we go. Number 2. Again, we're going to come back to this later. All right? We have our X is greater than 0, Y is greater than 0, so we're just going to be here in the first quadrant. 3 halves X minus 3. Now we're going below to start, so 1, 2, 3. That's where our starting point is on the Y-axis. But we're going to go up 3, right 2. Up 3, right 2. And I'm going to do my best to draw a straight line here. Not bad. Now I'm going to test 0, 0. 0 is less than negative 3. That is a false statement. So I'm going to shade this way. And then I have a y-intercept of 4 and a slope of negative 1, 1, 2, 3, 4 right there. There's a intersection point. 1, 1, 2, 3, 4. And I'm going to have this right here. And 0 is less than 4. That's true. So I'm going to shade here. Okay. Now the problem is this one is going to intersect somewhere out here. And that's actually going to be a corner point. Okay. So that's kind of an error in this problem. We'll just make up a point. Let's say it's, 14, 0. Okay. We're going to estimate. And then we have 2, 0 right here. And we have 3, 4, 1, 2, 3. 4, 3. Okay. And we're going to plug in, so half of 14, I'm glad I picked an even number, minus 2 times 0. So half of 14 is 7, minus 0 is 7. Half of 2 minus 2 times 0 again, well, that's 1. And half of 4 minus 2 times 3, well, that's negative 4. Definitely not going to be a maximum. So there's my answer. So we'll say the max is at, I remember this was an estimate, but we would actually find that pretty easily. All right. And actually, real quickly, since we know the slope, 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 1, 2, 3, 4. So that'd be 12. Actually, it'd be 16. So I was guesstimating it would actually work out to be 16 if you would keep counting down, and that would have been easy to find out. All right, now number 3. Again, we're going to be in our first quadrant here. X greater than 0, y is greater than equal to 0. Now this one is not in y equals form, but we can do the cover-up method. So if I cover up this and divide by 2, 4 divided by 2 is 2, so y is 2. And if I move this over here and cover this up, well, that's pretty easy. X is 4. 1, 2, 3, 4. So that's going to go right there. Just get a nice little spot there. All right. And we're going to shade 0 is less than 4. That's true. So we're going to shade right there. Next one, I'm going to cover up. All right. So it says negative y, negative 1y equals 1. So if I divide by negative 1, I got to be careful here. If I divide by negative 1, this is going to flip. And I'm going to end up with y, well, never mind there. Hold on. I'm going to get y of negative 1. We'll just go there right now. We'll get to the flipping later. And then, if I cover this up, well, x is 1. So that's right there. So this is a slope of 1. So it's just going to go 1, 1, 1, 1, 1, 1, 1. And we see we have a point of intersection there. Now, I don't have to worry about the flipping because if I plug in 0, 0 is less than or equal to 1. That's a true statement. So I'm going to shade this way. So what I have here is this little tiny quadrilateral right here. Okay? With 1, 2, 3, 4 points. At 0, 0, 1, 0, 1, 2, 1, and 0, 2. And now we're just going to plug those in. So I think you can see that this is just going to end up being 0. 3 times 0 plus 2 times 0 is 0. All right? 3 times 1 plus 2 times 0 is just 3. 3 times 2 plus 2 times 1 is 6 plus 2, which is 8. And 3 times 0 is 0 plus 2 times 2, which is 4. We're looking for the maximum, which is here. So the maximum is at 2, 1. And if you're asking for what the maximum is, it's 8. Okay, so back here, if we ask what the maximum is, it would be 7, and so forth. All right, here we go. Last problem. Now we're putting it all together. All right, Circle K rancher wanted to graze cattle and sheep on 1,000 acres of land. So we have cattle and sheep. All right, on 1,000 acres of land. That's going to be important. That's the total amount of land. Each acre can feed either 2 cows or 8 sheep, Okay? The manager can accommodate up to 3,200 animals, any combination of them. Now, remember, we're looking for that profit word. He makes $15 profit on cows and 4 on sheep. So that the profit is our objective function. So Z equals $15 for cows or cattle. So that's 15x plus $4 on sheep. So 4y. Now, what are my constraints? Well, he has 2 types of animals. And he only has 1,000 acres. So this is cattle for, acres for cattle and acres for sheep. Okay. So acres for cattle and acres for sheep has to be less than or equal to 1,000. That's all he has. Now, he can have 2 cows or 8 sheep. And it has to be less than or equal to 3,200 animals. And our ones we use every time, x greater than 0, y is greater than or equal to 0. All right? So now we're going to come down and graph these. So first off, it's a good idea to see how many spaces we have. Count up real quick. And I'm going to count by 100s. But I'm only going to write every 200 because it will get crowded. So here's 200. 400, 600, 800, and here's 1,000. Okay? And same thing here. And I'm just going to put the numbers 2, 4, 6, 8, 10. You know they're thousands. All right? Well, cover-up method for x plus y is 1,000 is really easy. It's 1,000 and 1,000 when you cover it up. So I'm going to do the straight line trick here to try to get this to work. That looks pretty darn close. All right. And then 2x plus 8y, 3,200. So I'm going to use the cover-up method on that one. I'm just going to bring this down. Nope. 8y, 3,200. All right. So if I cover up this, right? 8 goes into 32 4 times. So that's 400, right? So if my x is 0, my y is 400. And if I move this over to cover up my 8, that's going to be 1,600. So, whoops, that messed that up. There we go. 1,600, oh, comma 0. So, for x of 1,600, I need to go out to 12, 14, 16. So put a dot there. And 400 there. And I'm going to do the straight line trick again, see if I can get it to work well. All right. So if I shade, since they're both less than, it's going to end up being underneath this line and underneath this line. So where's the overlap? The overlap is here, 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 and here. That's my feasible region. So my points are 0, 0, 0, 400, 1,000, 0, and 800, 200. So obviously this is going to be 0. Now remember, we need our objective function, which was 15x plus 4y. Okay, I'll put that down here. 15x plus 4y. Okay, and I put 0, 0 because it's going to be 0. Now, 15 times 0, pretty easy, 0, plus 4 times 400 is 1,600. All right, 1,000 times 15, well, that's going to be 15,000. And 0 times 4 is 0. And then 8 times 15, 800. Is 12,000 plus 200 times 4 is going to be 800. So that leads us to 12,800. So our maximum is actually right here at 0, 400, which means 0 cattle and all sheep. 400 sheep. For a profit of, oh wait, my bad, that was 1,600. Never mind. I know how to read numbers. That was silly of me. Not 1,600. I thought it was 16,000 because I can't read very well. 15,000 right there. So in this case, it's actually 1,000 cattle and 0 sheep for a profit of $15,000. That's it.